Good morning, good evening, good afternoon. My name is Keith Pascal. Today we're going to talk about an introduction to TQL. So TQL or TQL is Topology Query Language, and that is a language that we use to get information from a configuration management database. It's a graphical tool that allows you to drag and drop. And that's a good thing because some of the TQLs that we create are very complex. And so the backend SQL would be extremely complicated. It's also a subsystem and it communicates with the UCMDB backend, runs those queries then the backend does, and sends the result sets back in memory to the system that is then going to display that. And queries are used all across UCMDB for analyzing, manipulating data, for processing data, for discovery, for integrations. There's numerous places that TQLs are used. So TQL is kind of the what and the how, right? The what being the data that we get out of UCMDB through the TQL subsystem. So you create your graphical query. That is the TQL subsystem. It sends that to the backend, which uses the data access layer to actually execute those queries, and then sends that data back and communicates with whichever subsystem it is that wanted the information. For example, correlation rules or reports, enrichments, views, input TQLs, discovery TQLs, trigger TQLs, integration points, so all across the UCMDB system. Let's take a quick look at how we can do these selects. So let's say, for example, that the CIs that we have in UCMDB are on the left. They are CI type 1, which is a square, CI type 2, which is a triangle, and CI type 3, which is a circle. Now, this is not a really complete representation because we also store directionality, which is a powerful thing. But for this example, this will do. Let's say we wanted in our TQL to show all of the triangles. Some backend SQL for that would be, say, select star from CI type 2. How many triangles would we return in the result set? You're right, 3. There are 3 triangles that exist. Let's say for a second example, we want all triangles that are connected to at least one circle. So, in this case, how many triangles do we have that are connected to a circle? There are 3 triangles connected to 3 circles. Now you'll notice that we only show 3 triangles and we only show 3 circles. In reality, there are several circles and there are several triangles that get picked up. For example, there's this set here, this triangle to this circle, this same triangle to this circle, this triangle to this circle, and this one to this circle. What we would actually return in memory are these discrete sets of triangles and circles. So we would actually return this one, this one, this one, and this one. That would be 4 triangles and 4 circles. Then we do a merge in memory of the same CIs so that, for example, this triangle is connected to 2 circles, not that we show 2 triangles which are the same representation of the same object connected to 2 separate circles. That would confuse the user so that they would believe that perhaps there are duplicates in their database. So we do get the discrete result sets and then merge them before we present them to the user. Now let's look at a little bit more complicated TQL. A triangle connected to a circle connected to a square. How many do we have in our database? Triangles that are connected to a circle that are connected to a square. And the best way to say that is actually a triangle connected to at least one circle which is connected to at least one square. That's correct. There's only one. There's only one in the database, and that is what we would return. Now, we have other triangles connected to circles, but not connected to a square. Those would not be returned because we need all three. Thank you very much for your time. I hope you have a great day.